So as we know that climate change has a significant impact on the whole cryosphere, especially on the glacier, where they are melting at a various rate in different parts of the world. And as we specific for the Arctic, where the temperature has been increased at the rate of more than twice as compared to the different region of the world. So we are interested to understand this climate change impact on glaciers in the Arctic because the melting of the glacier causing has an impact on a sea level rise, and within a kilometer, people living in the coastal area. So a small amount of sea level rise can have a big impact on population that are living near the sea level. So that's why it is necessary for us to develop automated method that monitor that glacier area changes in time. So to use this remote sensing, we are using that remote sensing approach in Google Earth Engine to map glacier in three different regions in Baffin, a part of the Baffin Island in Canadian Arctic, and Disko Island in the Greenland, and part of Kenai, Alaska. And we are mapping more than 1,700 glacier temporally at three different times using Google Earth Engine and object-based image analysis. So to map these glaciers, we are using mostly Landsat data, Landsat 5 for the earliest images available, and Landsat 8 for the most recent images available, and Landsat 7 for the images in between. So we kind of develop that workflow in Google Earth Engine that automatically map and generate a glacier's outline. So as you can see, we provide an input as a Landsat image. You can provide a Landsat 5, 7 based on the mentioned band in the input layers. You can change your number of bands or anything, but that's our input image, for example, as you can see in the figure. And this is in the figure, we can see our segmentation results. We are using a simple non-iterative clustering SNP as a segmentation technique in our study to segment the whole image. So in pixel base, we are training based on pixels to classify the image, but in here we are using these segments to classify the whole image. And an important thing is in here to mention that on these segments we can compute the mean or min max or standard deviation, and using that values we can classify the whole image. So these are the result of our segmentation, and based on these segmentation we train random forest classifier. So this is the in the picture, that is our results of our random forest classifier, and we apply median filter to just reduce the noise before we convert that classified image to vector. So then we convert that from raster to vector. So this is our whole automated methodology in Google Earth Engine, which is represented by the green box. So, and we use this methodology in different parts of the Arctic and tested in different parts of the Arctic. So for further analysis, for our post-processing, we take this outline, export this outline from Google Earth Engine to other desktop softwares, such as like ArcMap and QGIS to compute each glacier changes and to see if it's good, and to compute the method accuracy. So to see the method accuracy, the method showed an accuracy between 93 and 98% based on random sampling. So now, if we focus on the figure, that shows changes in each glaciers in three different areas in the Arctic. The ABC shows the changes in from 1985 to 2000, while DEF shows the changes from 2000 to 2019. and all these changes are in percentages. So we can have a clear idea. If I would have showed this in kilometer square, then the bigger glacier will show like the red area more. So and we can clearly see that the area has been the retreat has been increased in the second time period of the study. While if we see that A and D is the Baffin Island, that loss has a 452 kilometers square, and Disko Island lost 457 kilometers square, while Kenai, Alaska, 196 kilometers square plus minus 84. These uncertainties were calculated based on plus minus 30 meter buffer around these outlines. Uh, and the important there is a blue that might show you that increase in glacier, but actually that's we call a surge glacier that at the terminus has been advanced. So I will show you a single example of the glacier that have moved forward in especially in the Disko Island. So this is like if we see the terminus of in the Landsat 5 image, the terminus is way behind, but in 2000 the glacier has been surged and way moved forward, and in 2019 it just started to retreat back, and it's still. But the important thing is when it's retreat, it's also losing the area from the sides of the glacier. That's why in here it can be seen that the glacier have increased in length, but it actually lost the area in 2019. So that was the a summary of our work is to that using Google Earth Engine for glacier mapping is a potential tool, and that can easily cover larger areas such as Arctic, and we also providing a more than 1,700 multi-temporal outline for glaciers in these three areas. And we also find that the area loss was greater in the second time period of the study than the first. And further, I'm going to be presenting my talk on Friday morning. So I'm going to be discussing results in more detail. So you guys are welcome to attend. And now some of the work is still in process that we are looking at why these second time period changes are higher than the first time. So we are going to evaluate the temperature and precipitation. So that's still we're going to use Google Earth Engine for that. They have a data set of reanalysis, ER5. So we're going to use that to get the temperature and precipitation data. So and there's a one it's like and I already work, and so if if I'm going to work again on this method, so I would develop a little bit different. So I would make it more automatic rather than applying to each image separate. So some kind of I would create like some kind of function that work in the background and apply automatically to the three different data sets in the time. So I would do this, and if somebody is working in this area, so that is one way to go, I would think. And thank you for listening to me.